Can we all get a yes in the chat box? I've started the recording. Hey everybody, we're live and in stereo. Sir, how to make money? Well, this is a very good question, and I'd love to answer it sometime. The way you make money is that you do what you're passionate about, or even if you're not passionate about something, you do something that whatever thing that you are doing right now, you do it in such a way that you don't care about the time it takes, right? So that is when you start to make money. Money is just a byproduct of all your efforts and all your hard work. So there's gonna come a time, don't die before the shot is fired. So everybody has their own time to make money and to become Sir Suleiman and have businesses and do stuff. I'm joking, yeah. I'm kidding. Solve a problem in the form of a product. What? Okay, let's start. Now we're going to be solving 0620/22 October November 2021. It's a 45 minutes paper, and still students are joining, although I still waited 7 minutes, my god. But let me write my name. My name is obviously Suleiman Khan. Yeah. And without further ado, let me put a calculator by my side. And without further ado, let's start off with the paper. So it's the 062022 variant, and it's October, November 2021. And at the end, I can solve any paper that you guys request me to solve in an upcoming session. Why not? Sure. Okay, question number 1 says, an experiment is set up as shown. Cotton wool is soaked in ammonia. So obviously, if this cotton wool is soaked in ammonia, there will be ammonia vapors coming out of it. And there is another cotton wool which is soaked in hydrochloric acid, so obviously there's going to be hydrogen chloride molecules coming out of it. So we know that if there are vapors coming out, vapors are basically gases, and they're going to move in a random motion at high speed. So this is going to move, and we call this movement as diffusion. They're going to move from a region of high concentration to a region of low concentration. This will move from a region of high concentration to a region of low concentration. So both are going to move from high to low, right? Now the question is, where are they going to meet? Well, obviously they are going to meet at a point where the examiner has shown it to you guys. It's ammonium chloride forming here. Now you need to know why the ammonium chloride is forming here. The reason for that is that the factor that is going to determine where they will meet is their MR, is their relative molecular mass. So how do we know it's their relative molecular mass? Well, diffusion depends on two things. It depends on temperature and it depends on relative molecular mass, right? So if there is no mention of temperature, obviously the relative molecular mass is the only factor that is going to determine where they're going to meet. So if you calculate the MR of NH3, how do you calculate the MR? It's literally the sum of the ARs. So you look at the periodic table, the AR for nitrogen is 14, hydrogen is 1, and you have 3 hydrogens. So you times it by 3, you get 17. And hydrogen chloride, hydrogen is 1, chlorine is 35.5. You add them together, that's going to give you the MR, which is 36.5. Now, the lower the MR, the faster the molecules are going to diffuse. Why? Because it's very logical. A fat guy is 99.9% going to run slower compared to a thin or a slim guy or an athletic guy, right? Because he has a lower mass, right? So similar to that, the molecules also have a lower relative molecular mass. So the molecules that are thinner, that are skinnier, essentially, effectively, which have a lower relative molecular mass, are going to diffuse faster. So they're going to have a faster speed. That's why, if you check this out, the ammonium chloride is going to form more towards the hydrogen chloride, because the time it takes the hydrogen chloride to travel this much distance, the ammonia molecules have already traveled this much distance, right? So that's the concept behind it. Now it says, which statement explains the observation after several minutes? And obviously the reason why they're making ammonium chloride is because an acid-base reaction is going to take place. Ammonia gas is a proton acceptor because it's base, and HCl is going to be a proton donor. So obviously proton is the H plus ion, right? So when the H plus ion is donated here, NH4 plus is going to form and Cl1 minus is formed, which is essentially your ammonium chloride. So, and obviously you don't need to dissect the question to this much extent. The reason why I'm doing it is to revise your concepts, and that is all, right? That says, which statement explains the observation after several minutes? You guys are just going to read the question and go into the options, and then what you're going to do is you're going to eliminate each and every option. Please remember, these are general tips that I'm giving you guys throughout this paper. Please do not recheck your MCQs, right? So what you need to do is you need to be dead sure about an MCQ. And how will you be dead sure about an MCQ? Well, if your concepts are clear and you're able to eliminate why B, C, D are wrong, or why A is wrong, or why the other one is correct, that is going to help you in not wasting your time. So let's check it out. It says ammonia gas diffusion. Which statement explains the observation? Now we already know which statement explains it, but let's read the option. It says ammonia gas diffuses faster than hydrogen chloride, obviously because it has a lower relative molecular mass. So A is correct. But if you check B, C, D out, B says ammonia gas diffuses faster than hydrogen chloride because its molecules have a higher molecular mass. No, sir. If it has a higher molecular mass, then it should diffuse slower. And fun fact, it does not have a higher molecular mass. It has a lower relative molecular mass. Now it says ammonia gas diffuses slower. It diffuses faster. Ammonia gas diffuses slower. It diffuses faster. So that's how you can be certain about an MCQ that, hey, A is 100% correct. You don't need to check this out again at the end. Okay. A student puts exactly 25 centimeter cube of hydrochloric acid. So he needs something to measure the volume, right? And it says he puts it into a conical flask. The student adds 2.5 grams. How does he know that it's 2.5 grams? Well, he has to use a balance to actually weigh the mass, right? So he has to use the balance to determine the mass of sodium carbonate, which is 2.5, or else how in the world would he know that the sodium carbonate is of 2.5 grams, right? It's pretty common. And he's saying he is adding these two together. So he's adding sodium carbonate, which is a weak base, and hydrochloric acid. So an acid-base reaction is going to take place. And acid-base reactions are usually, all reactions, they either take in heat or give out heat. And he's using this particular reaction to find the change in temperature. So for him to find the change in temperature of this mixture, he obviously needs something to measure the temperature. So also he needs something to measure the temperature. And we know what we use to measure the temperature. We use a thermometer. Right, so that is what is used to measure the temperature. Now, B is automatically right off the bat wrong. Why? Because it has no mention of the thermometer. Now, it says which apparatus is correct. Now, if you check A, C, D out, A says balance. Okay, good enough. Balance will be used to measure this 2.5 grams. The measuring cylinder can be used to measure 25 centimeter cube of volume, but you need to be very careful here. The examiner has given you the volume up to 2 decimal points, sir. And 2 decimal points, the measuring cylinder has a least count of only 1 centimeter cube. Which means, what is a least count? You must have studied this in your physics. Least count is the smallest value that can be measured by a measuring instrument. So the least count is the smallest value which an instrument or apparatus can measure. And the measuring cylinder can only measure 1 centimeter cube. That's its least count, which means the smallest value that a measuring cylinder can measure is 1 centimeter cube. So it can measure 25 centimeter cube, and then 26 centimeter cube, and then 27. It cannot measure decimal points. And here he's given you 2 dp. For that, what do we use? Okay, so A is also wrong. But let's suppose you did not know why A was wrong. So let's suppose we don't know why A is wrong. Okay, let's check C, D out. C says a balance. Okay, good. A pipette. Yes, a pipette can be used because it measures exactly 25 centimeter cube, right? And a thermometer can be used. So C is correct. D says a burette, pipette, and thermometer. Dude, how do you use a burette for measuring mass? Burette is also used for measuring volume, right? So there's no mention of how he measures this 25 grams. So even if you did not know why A was wrong, between A and C, you could safely determine that the more accurate exact value would be obtained by circling C. But you need to know that the least count of a measuring cylinder is only 1 milliliters of 1 centimeter cube. So it wasn't A, those of you who said it's A. That's why I say to look at all the options, not just circle the one that you think is correct. A student separates sugar from pieces of broken glass by dissolving the sugar in water and filtering off the broken glass. It's pretty simple, yeah. He dissolved the sugar in water. So the sugar is going to dissolve in water because sugar is soluble in water. And then the broken glass, because it's insoluble, it's going to be collected as residue. The filter paper is going to trap it. And obviously the sugar sugar solution is going to be obtained as your filtrate. He's saying, what is the filtrate? Dude, we already know that the broken glass is my residue. That's the broken glass because it was the solid which was insoluble and it's trapped by this filter paper. And filtrate is basically my sugar solution because sugar has dissolved in water. It's not pure water, right? So it says broken glass. No, broken glass is the residue, Janab. It's the residue. Broken glass and sugar solution. No, filtrate cannot be the broken glass because broken glass is the residue. It has been trapped here. There's no mention. You remember the filter paper traps all these particles, these solid particles, right, which are soluble, obviously. So B is wrong. And C says pure water and D says sugar solution. Obviously, it's D. It's not C because it's a sugar solution because sugar has dissolved in water, right? So it has resulted in a solution. What is a solution? When a solute dissolves in a solvent, this mixture is basically called a solution. How many protons, neutrons, and electrons are there in one atom or of the isotope of aluminum 1327? Well, obviously in aluminum 27 is the nucleon number, which is the total number of protons plus neutrons. 13 is the proton number or the atomic number, which represents the total number of protons. So C and D are wrong. The selection is between A and B. Now, electrons for an atom is the same, right? Because it has no charge, the number of protons and electrons must be equal, and he's obviously given all the options as 13, so you didn't even have to think about that. Now, the difference is between neutrons. One is saying 14 and the other one is saying 13. Let's calculate this. Well, we know that the total number of protons plus neutrons, which is the nucleon number or the mass number, that is equal to 27. And we know that the number of protons are 13. So 13 plus n equals 27. N equals 27 minus 13, and that's going to give me 14 if I'm not wrong. Kindly tell me. Yes. So B is the correct option and A is wrong, right? And those of you who have learned this throughout the centuries, you guys can just say, hey, bade ko chote se minus karo. Subtract the smaller number from the bigger number. Which description of brass is correct? We know that brass is an alloy, right? And alloys are what? Alloys are mixtures of a metal with other elements, right? And brass is basically copper plus zinc. It's a mixture of copper and zinc, and it's basically an alloy. Now, it says alloy, yes, brass is an alloy. Compound, no, it's not a compound because there is no chemical reaction between copper and zinc. They are both metals. Element is only made up of one type of atoms. Here you have copper atoms as well as zinc atoms. Non-metal, janab, brass is not a non-metal. It's a mixture of these two metals. So D is also wrong. And you could also say that B and C are wrong because an alloy is not a pure substance. And compounds and elements, they are basically pure substances. Remember, alloy is a mixture. So it's not a pure substance. Mixtures are impure substances. So you need to know the concepts of pure substances and impure substances as well. Some properties of diamonds are shown, and it's saying which of these properties are also shown by silicon 4 oxide. They are both giant covalent structures. They are both very hard. They both do not conduct electricity. Why? Why are they hard? Because of strong covalent bonds, right? Why do they not conduct electricity? Because there are no delocalized electrons to carry the charge or to carry the electrical charge or the electrical current. It says every atom is bonded to every atom forms 4 bonds. Well, check this out. In diamond, each carbon is bonded to 4 other carbon atoms, right? And there's this tetrahedral shape. And you guys might think, hey, in silicon 4 oxide, our teachers have taught us that each silicon atom is also bonded to 4 oxygen atoms. So some of you might be deceived by checking option number 2 out as well. But the problem is, he's saying every atom, Janabe wala, this thing makes a difference. If he had just said that carbon and silicon form 4 bonds, then it would be correct. But every atom, no sir. Oxygen can only make 2 bonds. So each oxygen atom is bonded to only 2 silicon atoms. Every atom does not make 4 bonds. Only silicon make 4 bonds. And in carbon, every atom makes 4 bonds. Why? Because every single atom is a carbon atom and carbon can make 4 bonds. So that is what makes this option wrong, and 1 and 3 are correct. Therefore, C is the correct option. And even if you knew 1 and 3 are correct and you did not know whether 2 was correct or incorrect, you could have just looked at the options and select 1 and 3, right? So you have to be smart about things when it comes to execution. Which statement describes the attractive forces between molecules? Between molecules. So if there's this chlorine molecule and there's this other chlorine molecule, between these 2 chlorine molecules are simple. Their molecules form when there is a chemical bond between 2 atoms, right? And two or more atoms, but that chemical bond is basically the covalent bond, right? So that is how molecules form. So you're saying between molecules, so between molecules there are weak van der Waals forces or weak intermolecular forces of attraction. So it says they are strong covalent bonds which holds the molecules together. Remember, they are strong covalent bonds. Covalent bonds are not forces. He's saying what are the attractive forces. Okay, one misconception that students have, and it might even be tested. Remember guys, these covalent, if I talk about chlorine, this is the pair of electron which is shared, right? This covalent bond is also strong electrostatic forces of attraction. Sir, how do we know it's strong electrostatic force of attraction? Look at this. The nucleuses are positively charged and there is a sharing of electrons, right? So between negative, and electrons are obviously negatively charged. So between a positive charge and a negative charge, which force exists? Strong electrostatic forces of attraction. That is why covalent bonds are strong bonds, because in the covalent bonds there are strong electrostatic forces of attraction which hold these atoms together, not the molecules. Between the molecules there are weak van der Waals forces or weak intermolecular forces of attraction. So remember this, right? And based on these weak intermolecular force of attraction, you determine the melting point and the boiling point of these simple covalent molecules. Now, so remember, if he said there are strong covalent bonds which hold the atoms together, then it would be correct. But remember, covalent bonds are not forces. Even then you would have been skeptical about it, because forces are the electrostatic forces of attraction, right? Now it says, so A is wrong. It says B saying they are strong ionic bonds. Dude, ionic bonds do not make molecules, they make ionic compounds. They are weak forces formed between covalently bonded molecules. Yes, sir. Between these molecules, there are weak forces which we call the intermolecular force of attraction, right? And saying there are weak forces which hold the ions. Dude, cut me some slack. There are no ions. Which substance is described as macromolecule? Well, ammonia is NH3. It's a simple covalent molecule. Graphite is the macromolecule. It's a giant covalent structure, right? And here it's saying iron. Remember, graphite is not a compound. Many students, they confuse graphite and compound. They say they are giant covalent compounds. No, sir. Silicon oxide is a giant covalent compound because a compound is made up of two or more different elements chemically combined. Graphite and diamond are only made up of a single element, which is carbon. So we call them these macromolecules, or you can call them giant covalent structures or giant covalent molecules. You can't call them giant covalent compounds. And iron is a metal, janabe wala, so it's not a macromolecule, it's a giant metallic lattice. It's not a molecule. And sodium chloride again is a giant ionic lattice. It's a giant ionic compound. It's not a molecule. Okay, since the equation for the reaction of sodium and water is shown, what is the volume of hydrogen gas at room temperature and pressure produced when 18.4 grams of sodium reacts with excess water? So what we need to do is, from 18.4 grams of sodium, we calculate the moles of sodium, connect sodium and hydrogen together through this equation. Okay, hey, 2 moles of sodium gives me 1 mole of hydrogen. So these many moles will give me how many moles of hydrogen? And then you calculate the volume, which is using V is equal to N times 24, right? Because it's asked in decimeter cube. So how do we convert 18.4 grams into moles? Well, we say mass equals mole times molar mass. Mass is 18.4. Moles we don't know. The molar mass of sodium is 23. You check that out from the periodic table. 18.4 divided by 23, we get 0.8 moles, right? These are the moles of sodium, remember. And you know that 2 moles of sodium gives me 1 mole of hydrogen. So if there is 0.8 moles of sodium, how many moles of hydrogen would form? Well, obviously the answer is 0.4, right? Because if 2 moles are giving you 1 mole, 0.8 should give you half of that, which is 0.4, or you could cross multiply. And then you say, hey, you calculate the volume of hydrogen, we say N times 24, moles times 24, right? So 0.4 times 24, that is going to give me 9.6 decimeter cube, which is A. So the first step is always to convert the data into moles. Second step is to use the equation, and the third step is to convert it into the requirement of the question. Iron can be electroplated with zinc to make it resistant to corrosion, right? Now, he's saying iron can be electroplated with zinc. So we have to electroplate what? Iron or zinc? We have to electroplate iron, right? So let's suppose this is this bar of iron that you have. Now, in order to electroplate it, think about it. Try doing trial and error. If you get confused in these things, you can literally do trial and error. Well, how would you do trial and error? You make the positive terminal and the negative terminal, and then you try to add the electrolyte in it, right? So if you check the electrolyte out, it's going to be zinc nitrate or iron nitrate. Well, obviously, because you're coating iron with zinc, the electrolyte that you should use is obviously going to be zinc nitrate, right? You use the electrolyte of the metal that you are going to you use the electrolyte of a metal that you are going to plate on top of the other metal, which in this case is iron. So we're going to plate zinc on iron. That's why we need the electrolyte of zinc. Electrolyte is just a solution. Sir, what is an electrolyte? It's just a solution which conducts electricity because of free moving ions, right? And electrodes kya hote hain? They are solid substances which conduct electricity due to delocalized electrons. So now let's check it out. If I take my zinc nitrate, which is going to be the zinc 2 plus ions, and essentially we don't even care about the nitrate ions and so on and so forth. We care about the zinc 2 plus ions. Where will the 2 plus be attracted to? Will it be attracted to the negative terminal or the positive terminal? Well, obviously, because it is going to be attracted to the negative terminal, and you want the zinc to be electroplated on, you want the zinc to form its layer on iron, you should have iron right here, because the iron is going to have the negative charge all over it, and the zinc 2 plus is going to discharge here and is going to get deposited on this iron and form its layer, right? So this should be the iron. So the iron is effectively my cathode, right? Because we know panic, positive is anode, negative is cathode. So the negative terminal or the negative the negative electrode is known as your cathode. The electrode attached to the negative terminal is the cathode, and obviously the positive electrode is my anode, right? Now it says positive electrode पे क्या होना चाहिए? Positive electrode पे सर therefore zinc होना चाहिए, और होगा क्या? This zinc 2 plus is going to deposit on iron, and this zinc is going to start to dissolve in this solution to compensate for the zinc 2 plus ions. So you can even write the equation. At the cathode, zinc 2 plus ions will gain 2 electrons to become zinc, and at the anode, this zinc, the opposite is going to happen. This zinc is going to give you more zinc 2 plus ions by losing 2 electrons, right? So it's saying what is the positive electrode? The positive electrode is not iron, it is zinc right here as the positive electrode and zinc. And it says what is the electrolyte going to be? Iron nitrate? No sir, it's going to be zinc nitrate. So D is the correct option. Chlorine reacts with ethane to produce chloroethane and hydrogen. He's asking you the reaction is exothermic. See, even he is telling you that the reaction is exothermic. Based on this, what can you do? Based on this, you can calculate, you can eliminate two options. Remember, two options are always wrong right off the bat. So C and D are wrong. You just have to select between A and B. Now, the way I'm going to go about it is you can do two things. You can either waste your time and calculate the enthalpy change. And how do you calculate the enthalpy change? It's the energy taken in during bond breaking minus the energy released during bond formation, or the energy given out during bond formation. So you're going to break all these bonds. You're going to take its energy, and then you're going to form all these bonds, and you're going to take its energy, and you're going to take the difference between the two, and that's going to give you the enthalpy change. What I'm going to do is I'm going to be smart about it. I know the change in this molecule. Look at this. The only thing that is different from left to right is this bond and this bond. Right? So I can say that I'm only, going to take the difference. This and this is the difference. This is the difference right here on the left hand side, and that's the new substance that is being formed. So I'm only going to say, hey, this bond is being broken, and the chlorine atoms, this bond is going to be broken between the chlorine atoms, right? So what's the energy for it? The CH bond, it requires it 410 joules to break, right? That's the energy. And for the Cl-Cl bond, there is a 240 joules of energy that is required. So if I add these two, the total energy taken in during bond breaking is 650. But remember, that's not the reality. It's just a shortcut. It's not the reality. In reality, all these bonds are breaking. But if you think about it logically and mathematically, you'll understand understand that, hey, the energy that is taken in to break these bonds is going to be the same as the energy released when these bonds form. So they just cancel each other out. That's why I'm only taking the change, right? It's just for MCQs. अब तो theory चला गया तो MCQs में ये लगा लें. तो मैं theory के लिए ये कभी नहीं पढ़ाता था क्योंकि theory में आपका आंसर गलत आ जाता था फिर. Okay? So, and what is the energy given out when the bonds form? The CCl bond is forming. That's the change. So it's a 340 kilojoule per mole change. And the HCl bond is being formed, which is the energy for it is 430 kilojoule per mole. So what does that give me? That gives me 430 plus 340, that is 770. And because it's bond formation, we're going to add a negative sign to it, and we're going to add the positive sign right here. So enthalpy change is bonds broken, which is 650, minus bonds formed, which is 770. That gives me minus 120. B is the correct option. So you don't have to waste your time. Iodine gas is bubbled into aqueous potassium iodide. So if you have chlorine gas, Cl2 aqueous is bubbled in potassium iodide. So what's going to happen? Potassium iodide is a reducing agent, but even if you know your halogen reactions, you know that the more reactive halogen displaces the less reactive halide from its solution, or the less reactive halogen from its solution, right? So if you check this out, the chlorine is going to displace this iodide ion, and it's going to give you KCl, and I2 is going to form, right? And we know that I2 aqueous is actually brown, right? And most solutions, most aqueous solutions are colorless. Only transition metal ions solutions are colored because of the transition metal ion present. But other than that, almost all solutions, all aqueous solutions are colorless, right? So this is basically colorless. Now it says write the ionic equation. Well, what's the ionic equation? You could be smart about it and say, hey, chlorine aqueous is going to go, and this K is the same. This potassium ion is the same on the left hand side and the right hand side. So it's a spectator ion, right? In ionic equations, we do not mention the spectator ion. So you could say that, hey, it displaces this iodide ion to give you the chloride ion and I2 aqueous. And obviously, if I2 is here, there should be two iodide ions being displaced, right? Each chlorine atom will displace one iodide. So if you have two chlorine atoms, it's going to displace two iodide ions. Or you could just do balancing. One I here, two I's here, so add a 2 here. One Cl here and two Cl here, so add a 2 here. And that equation. And even if you did not go into this much technicality, if you are smart about it, you could save a lot of time. How? You know that I exists in the form of I2. A is wrong. Sir, Cl2 plus 2I minus and Cl2 minus, but in the world it's Cl2 minus. That's the first thing that I'm noticing, because chlorine is a molecule. How does it have a charge on it, right? And then if you check this out, Cl2, 2I minus, 2Cl minus, yes, this is the correct option. But even if you just pretended that you did not know the answer and just performed the elimination method, you know that I exists in the form of I2. D is also wrong. So without going into such technicalities, you could have literally selected option C. So this is what you need to do. You need to be smart about things. Done? Okay. Concentrated aqueous solutions of sodium chloride is electrolyzed. Which equation represents the reaction at cathode? Hey dude, we know this, yeah. The cathode is the negative electrode. That's the cathode, and that's the anode. And it's saying, what do you have? You have sodium chloride. So sodium ions, the chloride ions, and obviously because it's aqueous, you have the H plus ion and the OH minus ion. Between the sodium ion and the hydrogen ion, which is going to win the race? The hydrogen ion obviously wins the race. So two hydrogen ions go together, they gain 2 electrons and become H2 gas. And at the anode, what's going to happen? Chloride ion wins the race or the hydroxide ion? Well, we know the hydroxide ion always wins the race, except if the solution is concentrated and you have the halide ions. So yes, the chloride ion is going to win the race because you have the halide ion and the solution is concentrated. But he's not interested in that. He's just interested what's going to happen at the cathode. So at the cathode, 2 hydrogen ions gain 2 electrons and become hydrogen gas. A doesn't take place because sodium ion does not have a greater discharge tendency. Who cares what that means? B is wrong because B is not at all what happens, because there are no oxide ions in the solution. You have the hydroxide ions. C is wrong, D is wrong, because D happens at the anode, not at the cathode. This is how you need to solve the paper. I am explaining it. If I were to just solve it like this, it would take me 25 minutes to solve the entire paper. Just go bam, 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 bam. I have to explain it. That's my limitation. You guys don't. So you guys, when you are doing practice, you guys need to apply these methods, because after this, you don't have to check your options. Not at all. If you think an MCQ requires reading like this particular MCQ or this particular MCQ, skip it out. Move forward. Come to it at the end. Okay. Which statements about hydrogen are correct? Now, when hydrogen is burnt, heat energy is released. Obviously, that is why hydrogen is used as rocket fuel. When hydrogen is used in a fuel cell, electrical energy is generated. That's what happens in hydrogen fuel cell. Hydrogen oxygen fuel cell mein hydrogen and oxygen react together to give H2O, and electricity is generated. When hydrogen is used as a fuel, water is the only product, and that's the benefit of hydrogen fuel cell, that it produces water as the only chemical product, compared to petrol engines, where you have petrol producing carbon dioxide, right? So A is the correct option. Solid X is heated strongly. The color of this solid changes from blue to white. What is solid X? Anhydrous cobalt chloride. One more thing. Some people might think, hey, anhydrous cobalt chloride is blue. Let's select option number A out. Oh, you dumbo. It's saying anhydrous. Anhydrous already means it has no water molecule. To carry heat kar rahe ho. Solid X ko already it has no water molecule. If you further heat is, mumkin hai that this salt starts to decompose. It starts to degrade. It starts to break down. आप इतना इसको ऐਵੇਂ heat कर रहे हो. Already anhydrous में कोई पानी नहीं, आप क्या heat कर रहे हो? तो nothing is going to happen. It's just going to remain brew, and even the salt might even break. Calcium carbonate. I have not studied anything like that for calcium carbonate. Neither have I taught anything like that. Hydrated copper sulfate. Yes, sir. Hydrated copper sulfate is actually blue, and if you strongly heat it, well, copper sulfate dot 5H2O, that's hydrated copper sulfate, and if you strongly heat it out, it's gonna the water molecules are going to evaporate. It's gonna become anhydrous, and obviously anhydrous copper sulfate is white, so that's blue and that's white. C is correct. And D, I have not studied anything like this for this. So see, B and D were wrong off the bat. You just have to check between A and C. Iron 2 chloride solution reacts with chlorine gas. Do I have everybody alive? There are quite a few students, and everybody's just so quiet. Either you all are getting every single thing, or you guys are getting nothing. These are the two. Our professor always used to tell us, when students are quiet, that means either they are getting everything is very easy, or they are not. Just everything is just going off the top of their head. Yeah, everything's easy. Yes. अभी तक सही लग रहा है कि नहीं, मुश्किल लग रहा है, बताओ भाई. Don't put me in a conundrum. Easy peasy. Oh, Maha is here. 10160 saying easy. I'm seeing a lot of new names here, so most of you don't know me, so I'll introduce myself at the end, right? Because there are a lot of new names. मेरे जो अपने पढ़ाए हुए बच्चे हैं, उनको ही इधर नहीं बैठा हुआ. कह रहे हैं सर टाइम ज़ाया कर रहे हैं हमारा. Okay. आयरन 2 क्लोराइड सोल्यूशन, और अगर इनमें से किसी का ए आ गया ना, मैंने फिर सबकी गिचियाँ दबा दी नहीं है जो ये सोच रहे होंगे. याद रखिएगा, मैं रिकॉर्डिंग में कह रहा हूँ, अदीना, युसरा और जितने सारे मेरे माशाल्लाह घर पे बैठे हुए हैं, एंजॉय कर रहे हैं, याद रखिएगा ये रिकॉर्डिंग आप देखेंगे, मुझे पता है. तो वो अगर आपका ए आ गया ना, फिर मैं जानूँ और आप जाने. अस्तगफुर. हमारे प्रोफेसर होते थे, वो कहते अल्लाह सबको खुश रखे, अल्लाह सबको खुश रखने अपने खर्चे पे. अल्लाह ताला आप सबको खुश रखे अपने खर्च पे. ओके. आयरन 2 क्लोराइड सोडियम. ओके, सोडियम कह रहा हूँ. आयरन 2 क्लोराइड solution reacts with chlorine gas. The equation is shown. Okay, great stuff. He's saying what statements are correct. So he's talking about reducing agent and oxidizing agent. Let's talk about this. So iron here is +2. Chlorine is -1. Here Cl2 is in its pure elemental state, it's 0. Iron here is +3 and chlorine is -1. Because chlorine is in group 7, so it's always going to be -1. How do I know iron is +2 and +3? Well, iron chloride, right? So it's saying FeCl2. How was FeCl2 formed? Well, obviously Fe had a charge of 2 plus Cl was 1 minus, and the oxidation state of any ion is its charge. That's why when you cross multiply, you ended up with FeCl2. So the charge on iron is 2 plus, therefore the oxidation state is +2. Similarly here, it's FeCl3. So if you go back, do reverse working, iron has a charge of 3 plus and Cl is 1 minus, therefore the oxidation state is plus. Or you could say, hey, iron is X, I don't know, chlorine is minus 1, you have 3 chlorines, times it by minus 1, so X minus 3 equals 0, and then minus 3 shifted on the right hand side, you get plus 3, same thing. Now if you check this out, iron goes from plus 2 to plus 3, which means what? Which means that iron has literally lost an electron, right? There is an increase in oxidation state. Iron went from plus 2 to plus 3, yeah, by losing an electron. So there's an increase in oxidation state, that's oxidation. And chlorine is going from 0 to minus 1, so that's reduction. Why? Because there is a decrease in oxidation state. That says Fe2 plus ions are reduced. No sir, they are oxidized, yeah? They go from 2 plus to 3 plus. So how are you saying this, you dumb person? Chlorine acts as a reducing agent. Remember, reducing agent is any chemical substance which oxidizes itself to reduce others. Many students get confused with this, and I explain this through a marketing agent. What does a marketing agent do? He markets for you. Reducing agent. This is an agent which reduces others. So a reducing agent reduces others. And how does it reduces others? By oxidizing itself. How do you know that? Well, Janabe Wala, when you get oxidized yourself, you lose an electron, and that electron actually reduces another substance. Therefore, whenever there's oxidation taking place, or whenever you have something getting oxidized, that particular substance is a reducing agent. Whenever something is being reduced, that particular substance is an oxidizing agent. So it's opposite, right? So if iron 2 plus is going into iron 3 plus, that's being oxidized. This is the reducing agent. And chlorine is being reduced, so that's the oxidizing agent, not the reducing agent. So that's 2 is also wrong, you dumb person. And option सिर्फ 3 4 रह गए, चेक ही नहीं करना, डी लगा लूँ सर्कल, लेकिन चेक कर लें. Iron 2 plus ions is each lose an electron. Yes, they do lose an electron. Yeah? That's why it's oxidation. And chlorine molecules are reduced to chlorine ions. Absolutely they are. Which statements about acid, bases and salts are correct? An acid reacts with a metal to give off hydrogen. Yes, any metal plus acid gives salt and hydrogen. Right? So that's correct. A base reacts with ammonium salt to give off ammonia. Absolutely they do, because that's ammonium salts are slightly acidic. So an acid-base reaction takes place. Salt is formed, ammonia gas is formed, and H2O is formed. An acid reacts with carbonate to give off carbon dioxide. That's also correct. Astonishing, because whenever a metal carbonate reacts with an acid, it gives you salt, H2O, and CO2, right? Alkaline solutions are orange in methyl orange. Oh no, you dude, alkaline solutions are yellow. You know, this is the examiner is just playing a stupid game at this point. He's giving you the word orange, so he thinks you're gonna circle orange. The joke's on you, dude. We know that methyl orange is basically yellow in an alkaline solution, and it's red in an acid solution, right? But the examiner tried to be cheeky with us. Sucker. So 1, 2, 3 are correct, therefore A is correct. And for those of you who are going to be giving variant 4, 3, remember that methyl orange is only orange in a neutral solution, but in MCQs it's not going to be tested. And for O levels IGCSE students, that's not in your course. 4, 3 students जो है उनको पता है. Oxide 1 is a solid that reacts with dilute hydrochloric acid. So if oxide 1 is reacting with a dilute hydrochloric, it's oxide, which means it's basically like either a metal oxide or a non-metal oxide. If it's reacting with dilute hydrochloric acid, it must be a basic oxide. Why? Because acid reacts with bases, right? So it must be a basic oxide, or it can also be an amphoteric oxide. Remember, guys? Because amphoteric oxides can act as a base when reacted with an acid, or can act as an acid when reacted with a base. So it can either be these two. Oxide 2 is a gas, जनाबे वाला. देखिए आप मेटल ऑक्साइड्स तो गैसेस होते ही नहीं है, मेटल ऑक्साइड सारे सॉलिड्स होते हैं, तो एक नॉन मेटल ऑक्साइड होगा. लेकिन इवन दो ही इज गिविंग यू दिस मच इंफॉर्मेशन यू कैन डिड्यूस, बट ही इज फर्दर एक्सप्लेनिंग इट. ही इज सेइंग इट रिएक्ट्स विद सोडियम हाइड्रोक्साइड. So sodium hydroxide is base, right? Sorry. Sodium hydroxide is alkali, it's base, it's an alkaline solution. So if it's reacting with a base, this must be acidic. And acidic oxides are your non-metal oxides, and they're usually gases because they're simple covalent molecules. Easy. So oxide 1, now check this out. Is oxide 1 nitrogen dioxide, sulfur dioxide? Even if I had not gone into the technicalities, I know he's saying it's a solid, and nitrogen dioxide and sulfur dioxide are not solids, they are gases. So B, C and D are automatically wrong. A and B, check this out. A says calcium oxide and magnesium oxide. Well, it can be either or. It can be either or. Check oxide, check option B and check oxide 2 out, sorry. So oxide 2 says metal oxide. Magnesium oxide is a solid. It's not a gas. So even if you did not know about these properties, you could safely deduce, hey, this is a solid, that's a gas, B is an answer. Save your time as much as you can. I have to obviously explain things. You guys don't. You guys don't have to give explanations to the examiner. You guys have to just select the MCQ, right? But you have to go through the elimination method. Which reaction is a photochemical? Photo means light. So that reaction should involve light. Addition of bromine to propene is not a photochemical reaction because this occurs at room temperature and pressure in a dark room. Remember, these were its conditions. Esterification, no sir, esterification may you use conch H2SO4 and 200 degrees Celsius you heat it till that. Oxidation of ethanol, you use KMNO4 acidified potassium manganate or acidified aqueous potassium manganate or acidified aqueous potassium dichromate, who cares. Substitution, yes, CH4 reacts with chlorine only in the presence of UV light. So because light is involved here, D is correct. The equation shown represents a reaction at equilibrium. This is a good question. M and N represents the balancing numbers for the reactants. Okay. A high temperature increases the concentration of Q. Sir, high temperature favors endo or exo? High temperature favors endo. So that means if Q is being made, that means the forward reaction is endo and the backward reaction is exo. Done? And says a high pressure increases, the high pressure favors fewer moles of gas, fewer gaseous moles, right? And you only have gases. अच्छा theory में इतने बच्चों ने ये blunder मारा है, एक दो मेरे स्टूडेंट्स ने भी एक दो ने ये ब्लंडर मारा है, हालांकि इट्स वेरी क्लियर यार. अगर आपके पास एक साइड पे देर आर नो मोल्स ऑफ गैसेस एंड इन द अदर साइड यू हैव 4 मोल्स ऑफ गैसेस, बच्चों ने कहा हो इंक्रीज द प्रेशर फेवर्स लेस नंबर ऑफ मोल्स ऑफ गैस. राइट पे तो मोल्स ऑफ गैस ही नहीं है, तो लेफ्ट पे डाल दो. ओ भाई मोल्स ऑफ गैस राइट पे नहीं है, तो देर आर 0 मोल्स ऑफ गैस ऑन द राइट एंड देर आर 4 ऑन द लेफ्ट. सो यार इज गोना फेवर द 0 मोल्स ना, 0 मोल्स फ्यूअर मोल्स ही हो गए. So please, so it says if you increase it, so it favors fewer gaseous moles. Fewer gaseous moles को अगर ये favor करे, concentration of Q बढ़ रहा है, which means that N should be more or less than M. Well, N should be the fewer number, right? So we know that M is greater than N, or you could say N is smaller than M. Great. Which statement is correct? The forward is exo? No. The forward is exo? No. See, saying exo, 2 are wrong off the bat. And forward is endo. M is greater than N, yes. And the forward is no. D is not correct. Yeah? Done? Moving forward? Easy peasy lemon squeezy. अच्छा कुछ बच्चे काफ़ी इसमें नए हैं, तो शायद आप लोगों को आज मज़ा आ रहा हो. सर व्हाट इज़ योर यूट्यूब हैंडल? अफनान जवाद साहब आप मेरे फ़ैन बन गए हैं. सीरियसली यार, आई लाइक टू कीप दिस लो की प्रोफाइल, एंजॉइंग चिलिंग. कुछ स्टूडेंट्स कहें यार बंदा अच्छा कभी कभार ना मैं थोड़ा सा ज़्यादा एनर्जेटिक होता हूँ, जो नए बच्चे हैं उनको बता दूँ डिस्कशन फोरम से, तो मैं थोड़ा सा ज़्यादा एनर्जेटिक हूँ. उन्होंने आजकल काम इतना ज़्यादा कि मेरी वो एनर्जी नहीं है, तो वरना तो मैं एनर्जी इधर उधर जा रही होती, आपकी सांस साथ साथ निकल रही होती कि ये बंदा पता नहीं व्हाट इज़ ही डूइंग, इज ही लाइक वाटर वाइट और समथिंग. नो, आई डोंट इवन हैव कॉफ़ी. या so chill out. Okay, a periodic table is shown R as W blah 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 blah. It says which statement is correct, and he even, you know, the examiner has to be so careful because she thinks that you guys are so stupid because he's telling you the letters are not their chemical symbols. भाई आपका हाथ जोड़ रहा हूँ, R S T U V, there's nothing, no such thing in the periodic table as these. So please don't be stupid. That's what the examiner is doing. He's like literally आपके हाथ जोड़ रहा है कि बस माफ कर दो, लिख लिया R S W. Okay. Element R does not conduct electricity. Oh you dumbo, element R is in group 1. Group 1 means it's a metal. Metal has delocalized electrons. Delocalized electrons can carry electrical current, or it can carry charge, which can obviously conduct electricity. What are you talking about? R and Y react together to make an ionic compound. Y is group 7, R is group 1. You know, like sodium chloride, sodium is in group 1, chlorine is in group 7. So there is a transfer of electron from metal to non-metal, forming oppositely charged ions held together by strong electrostatic forces of attraction, which is called an ionic compound. Somebody sing C. Z exists as a diatomic molecule. Oh, you dumbo. Z is group 8. Group 8s are noble gases. They are monoatomic, not diatomic. Z reacts with element T. Z are noble gases. Noble gases don't react. Although that's not totally true. But for OA levels, yes, they don't react. all metal nitrates are soluble in water, all metal chlorides, all blah blah blah. Which aqueous solutions produce a precipitate? Remember, whenever you talk about precipitate, this is a rule of thumb that you need to do, and that is make a beaker and put in all the ions, right? Because when he's forming a precipitate, he must take two soluble substances, right? So he has silver nitrate, so he has the silver ions and the nitrate ions, and he has sodium carbonate, so he has the sodium ions and the carbonate ions. Now, bump all of these ions into each other. So when the sodium ion is bumped into the nitrate ion, it's soluble. When the silver ion is bumped with the sodium ion, they repel each other. When the silver ion is bumped into the carbonate ion, sir, he's saying that all metal carbonates are insoluble except for sodium and potassium, so silver carbonate is going to form a precipitate. Done? Now make this out. Silver ion, nitrate ion, sodium ion, chloride ion, and check this out. He's saying, check out chlorides. He's saying all metal chlorides are soluble except lead and silver. So, sir, when silver ion comes into contact with chloride ion, it's gonna make silver chloride, precipitate banega. Barium nitrate and potassium chloride. Remember, just draw a beaker, yeah? So barium nitrate means the barium 2 plus ion, the nitrate ion, potassium ion, chloride ion, and bump all of these ions into each other. Sir, no precipitate is going to form. Why? Because barium chloride is soluble. How do we know? He stated this. All are soluble except for silver and lead. So silver and lead nahi hai, isme barium hai, so that's soluble. Potassium nitrate, all nitrates are soluble. Barium chloride, all chlorides are soluble except for silver and lead. So barium chloride is soluble. Potassium and chloride ion, they are already soluble. Barium and nitrate, they are already soluble, so no precipitate forms. 1 and 2 are correct, yeah? Of below. Which row describes properties of transition element? Sir, sans le le. Transition element properties. Colored compounds, high density, high melting point, low melting point. Sir, transition elements have high melting points, no low melting point. D is wrong. One more thing that you all need to realize is you guys make this huge mistake between the chemical properties and the physical properties of transition metal. Here he's just used the general word properties. Physical properties includes density and melting point. Chemical properties includes colored compound, and it has variable oxidation state, and it acts as catalyst. These three are the chemical properties because there's a chemical reaction taking place. There's a chemical change that takes place. So physical property is just a change in appearance. If you melt this metal, if you melt a transition metal, it's still going to be an iron. It's iron solid, iron liquid. It's still iron. There's no chemical change, no chemical reaction table. It's only a change in appearance. That's why we call it physical properties. So remember to differentiate between chemical and physical properties. And I reckon, this is my hunch, that this particular MCQ will be asked in such manner in this paper. Or not in this one, but in the paper that you'll be appearing in. Okay. So A, B, C are correct. Let's look at property 2. High density, high melting points, colored compounds, all 3 are correct. Variable oxidation state 1, 1. No, sir, it does not have one oxidation state. It has variable oxidation state. So A is correct. The noble gases are in group 8 of the periodic table. Let me check कितना time हो गया. Oh, 46 minutes हो गया. Allah Allah. तेज हो जाऊं थोड़ा सा. थोड़ा तेज हो जाऊं. इजाजत है? इजाजत है? Can I pace up, please? Well, it's wasting a lot of my time. I have to go. Take a shower, get ready, go out, eat pizza. Okay, let's pace up. Okay, thank you for giving me the chance. Let's 2x. The noble gases are in group 8. We know noble gases do not react. Why do they not react? Because they have a complete outermost electron shell. Sir, why do they not react? Why are they unreactive? They all have 8 electrons. No, sir, that is wrong. This is a very typical question that the examiner asks, and you guys get it wrong. Why? Because helium is also a noble gas, and it does not have 8 electrons in its outermost shell. It only has 2 electrons in its outermost shell. How do we know that? You can check the periodic table out. We don't say it has a complete octet. We say it has a complete duplet, right? Because it only has one shell, and that's the complete shell. So A is wrong. They have full outer electrons. Yes, they have full outer electrons. Some has 8 and helium has 2. They are all gases. They are all gases. Yes, they are all gases, but that does not explain why they are unreactive. फिर तो chlorine, bromine भी, chlorine वगैरह भी unreactive होता है. They are all monoatomic. Yes, they are, but that does not explain it. Which statement is correct for all metals? All metals, remember, they conduct electricity when molten. Sir, all metals conduct electricity regardless of the state because they have delocalized electrons. They gain electrons when, sir, they don't gain electrons, they lose electrons. They have a low density. No, sir. Metals, not all metals have low density. Only group 1 metals have relatively low density. That's why they can float on water. They have a low melting point. Only group 1 metals have a relatively low density, and that's why he's talking about all metals. Carbon dioxide is produced during an extraction of aluminum from bauxite. Obviously, carbon dioxide is produced during the extraction of aluminum from bauxite. Why? Because the oxygen, you melt the aluminum oxide, so you have the O2 minus ion, it goes at the anode. The O2 minus ions, they lose 2 electrons to become O, and obviously you have O2 being formed, so 2 oxide ions go together, and in total 4 electrons are lost. And this oxygen that forms at the anode, because the anode is made up of graphite, which is carbon, this is going to react with this oxygen to give carbon dioxide. Done. It says carbon, which statement explain this? Carbon monoxide reduces, oh you dude, carbon monoxide किधर से आ गए, electrolysis हो रही होती है. Carbon is burnt in blast furnace. भाई ये hematite की extraction तो नहीं है. A and B are wrong off the bat. Oxygen is made in the process which reacts with the carbon electrode. Absolutely, sir, you are right. The ore of aluminum undergoes thermal decomposition. Thermal decomposition means the breakdown of any substance by applying a lot of, by providing a lot of heat to it, right? By heating it in the absence of oxygen. जनाब वाला इधर कैडी हम heat कर रहे हैं, कोड़ी तो हम उसको melt कर रहे हैं और melting के बाद electrolysis करें, कैडी thermal decomposition. There's a difference between thermal decomposition and melting. Aluminum objects do not need protection from corrosion. Why? Because it forms a layer of its oxide which protects us from air and water and whatnot, right? So which aluminum does not form ions easily? No, it's a metal. It does form ions. It's relatively at a very high level in the reactivity series. Aluminum does not react with water or air. No, sir. Aluminum does react with water and air. Its oxide does not react with water and air. Yes, C is correct. It forms a protective layer of it. Basically क्या होता है, एल्यूमिनम है, ऑक्सीजन के साथ ये ऑलरेडी रिएक्ट कर चुका होता है, Al2O3 बनता है, तो ये एल्यूमिनम का मेटल है और इसके इर्द गिर्द, दिस इज द एल्यूमिनम मेटल एंड देयर इज दिस प्रोटेक्टिव लेयर फॉर्म, सो इट प्रिवेंट्स ऑक्सीजन एंड H2O from coming further into contact with this aluminum. Aluminum is below iron? No, sir. Aluminum is below iron in the reactivity series. Firstly, this is wrong. It's not below iron in the reactivity series. It's above iron in the reactivity series, and that still does not explain why it resists corrosion. Which statement explains why zinc is used to protect iron from rusting? Well, because zinc is more reactive. You attach a block of, or what you could do is you attach a block of zinc to iron, or you either coat it with zinc. When you coat it, you call it galvanizing, and when you just attach it to iron, you call it sacrificial protection. So what happens is oxygen आएगा, oxygen iron के साथ react अगर कर भी लेते हैं, वो कहानी बाद में पढ़ेंगे. But what zinc does is, zinc is more reactive than iron, so therefore it loses the electrons, it oxidizes itself, sacrifices itself to protect iron, right? And even if iron reacts with this oxygen, I used to think about this a lot, right? I used to think, hey, zinc is attached here. What if the oxygen comes into contact with iron here? Well, it can, and then iron oxide is going to form, which is essentially rusting. But since zinc is more reactive than iron, it's still going to displace the iron from its oxide, and zinc oxide from an iron still is remained unharmed, right? So it says zinc is more reactive than iron. Yes, sir. Zinc is less reactive than iron. No, sir. Zinc can form alloys with iron. Absolutely wrong. There's no concept of alloys here. Zinc acts as a sacrificial metal. Yes, it sacrifices itself. So B is correct. Which conditions are used in Haber process or Haber process? Sir, A and D are wrong. You have a temperature of 450 degrees Celsius and a pressure is of 200 degrees Celsius, not of 10. A pressure is of 200 atmospheres, not 10 atmospheres. Which process does not produce a greenhouse gas? Remember, greenhouse gas is methane as well as carbon dioxide, right? These are very, very crucial to this climate change. Acid rain on limestone buildings does not produce. Remember, acid rain, let's suppose you take any acid, take like HNO3, right? So we have nitric acid, and limestone is basically calcium carbonate, which is a metal carbonate. So obviously metal nitrate is going to form, H2O is going to form, and carbon dioxide is going to form, which is basically a greenhouse gas. Combustion of wood. Remember, sir, combustion of wood. Wood is a living thing. Wood मतलब tree का हिस्सा होता है ना. Tree is living. So living substances are made up of carbons and hydrogen. So if you combust them, in combustion we know carbon dioxide and water is produced. So carbon dioxide is produced here. Digestion of cows. When cow digest food, they have dung, and that dung releases these toxic fumes, and that burns your nostrils, but it also produces methane, and that's why it can be used as biogases, right? So C is wrong because this produces methane, right? वो देखा होगा जो बच्चे गांव वगैरह में रहते हैं, वो दीवारों पे उन्होंने थापे होते हैं, पश्तो में पता नहीं उसको क्या कहते हैं. Zinc reacting with sulfuric acid. Well, when zinc reacts with sulfuric acid, when zinc reacts with an acid, it gives what? It gives a salt and hydrogen gas. So D is correct. And please, you don't need to prove these things. When you are solving the MCQ, you need to be very sharp. आपने ना एक क्विक लुक देखनी, ग्रीन हाउस गैस नहीं बनाता, अच्छा मे बी बनाता हूँ, मे बी करता हूँ, जिंक रिएक्टिंग विद सल्फ्यूर, ये तो श्योर शॉट हाइड्रोजन बनाता है, डी इज करेक्ट, राइट? सो यू स्किम थ्रू, बट रिमेंबर ऑलवेज चेक ऑल द ऑप्शंस आउट. अड़ना नहीं है, अगर आपको ये समझ नहीं आ रही तो अड़ना नहीं है, आपको सही आंसर मिल गया तो अब इसके साथ लड़े ना कि अच्छा ये क्यों गलत होगा. सर ने कहा था हर एमसीक्यू की मत मार रही है, प्लीज अल्लाह अल्लाह करें, अल्लाह का खौफ करें, ऐसी भी कोई बात नहीं है. You know, it depends on your execution. I have given you a general way of going about the MCQs. I don't, so that you guys are not misled or you don't come and, you know, you don't succumb to the time pressure. So I have given you a general advice. You can mold it as per your requirement when you're sitting in the paper according to the circumstances of the situations that you are posed with, right? Which reaction is involving sulfur dioxide is correct? It is produced from the extraction of, okay, this particular MCQ has now been removed from your course because zinc blend has now been removed, but I'll still explain it. It is produced during the extraction of zinc from zinc blend. Zinc blend is zinc sulfide. What we do is we take this zinc sulfide and we react it with oxygen, right? And what happens is you end up with zinc oxide and sulfur dioxide, and then the zinc oxide is further reduced by carbon to give you zinc and carbon monoxide, right? Or carbon dioxide, who cares? But sulfur dioxide is produced right here. So he is correct. It is produced, but this is no longer in your code. It says it reacts with conch sulfuric acid to form oleum. No, SO3, this is also removed. SO3 reacts with H2SO4 to give you what? H2S2O7, which is the fuming thick liquid called oleum. And you react this oleum with water to give you 2 moles of sulfuric acid. It reacts with sulfur to form sulfur trioxide. Janabe wala, sulfur dioxide reacts with oxygen to form sulfur trioxide, and that's the reversible equation that is only left in your course. It turns acidified solution of potassium magnate purple? No, it turns it colorless. Potassium magnate is purple. It turns it colorless, right? Because it's a reducing agent. Lime is calcium oxide. It's a base. And it is used to treat water from a factory. Which substance is removed by lime? Which substance is removed by lime? Tell me, anybody. Well, you're using a base. No, sir, C is not correct. Well, look at this. Ammonia is a base. Sodium chloride is a salt. Why would this salt react with a base, right? Acids react with bases. Ammonia is the base. Base does not react with a base. So A, B, wrong. Sodium hydroxide is an alkali, a base. No, wrong. Sulfuric acid. Yes, the calcium oxide will react with sulfuric acid to neutralize it, to give you salt and water. And obviously this sulfuric acid would be neutralized and you would be protected, or the wastewater would safely be returned to the environment from which we stole this water. Sir, is this flue gas desulfurization? Flue gas desulfurization is a very particular term used for the removal of sulfur oxides from the air. So yes, calcium oxide is used in flue gas desulfurization, but we use it to remove the oxides of sulfur. Sulfur dioxide ho gaya, sulfur trioxide ho gaya, not sulfuric acid. That's just a simple acid-base neutralization reaction. Okay, Ryan? So I hope it makes sense, right? Yeah, like if you talk about flue gas desulfurization, you can take calcium oxide, react with SO2, you're going to get CaSO3, calcium sulfite. So here you've successfully removed sulfur dioxide from the air. What is the structure of ester formed from ethanoic acid and propanol? Well, if you check this out, we know that the acid is going to give you the acid is going to lose the hydroxyl and which is the OH, and the alcohol loses the H, right? And if you want me to make it for you, it's pretty stupid, but I can still make it for you. Remember, that's my ethanoic acid. That's how you make the ethanoic acid, and that's how you make meth at the prop. And the functional groups should face each other. Why? Because obviously the alcohol loses the H and the acid loses the OH to give you H2O, and that is the structure that's gonna form. So you guys can check this out. ये कैडी structure है, किधर मिल रहा है आप check कर सकते हैं, और आपको दिखेगा कि that's option number D out, right? But I can also explain it by eliminating all the other options. Check this out. This is the carbonyl carbon, which is C double bonded to O. Whenever there's a C double bonded to O, you call it the carbonyl carbon. All the carbons attached to the carbonyl carbon comes from the acid. That's meth, eth, prop. This came from propanoic acid, not ethanoic acid, right? So A is wrong. Check B out. B is again meth, eth, prop. That's also coming from propanoic acid. That's not ethanoic acid. The name should be propyl ethanoate, sir. Again, check C out. C isn't even an ester, yeah. C को क्या कहते हैं? Sir, C को हम कहते हैं ketone, not a part of your course. But look at this. This is C double bonded to O. Where's the other bond? Where's the bond with O? Ester linkage होना चाहिए ना. आपने polymers में you've studied that this is the ester linkage. Sir, C carbonyl carbon bonded to the O, that's the ester link. He's just a C double bonded to O bonded to another carbon. It's nothing, it's not an ester. That's a ketone, who cares? And D is left, that's meth ethanoic acid, meth prop, that came from propanol. So that's propyl ethanoate. Fuel X produces carbon dioxide water when it is burned. So does fuel Y. What could be X and Y? Janabe wala, fuel X and Y both will produce both carbon dioxide and water. When carbon is burnt, it only produces carbon dioxide. You dumbo. A and B are wrong. C produces, well, obviously methane produces, it's a fuel, it's an alkane, it will produce carbon dioxide and water when it undergoes combustion. Hydrogen, sir, hydrogen, when it reacts with oxygen, it gives you H2O, right? Pani, our beautiful pani, yeah? So that's also wrong. D is the correct option because that's your octane and that's my methane, and they're both alkenes, they're both fuels, will undergo combustion to give carbon dioxide and water and large amounts of energy. The structures of 4 organic molecules are shown. Acha, those of you who watch this video later on, आपको मैं मज़े की बात बताऊं, this might be an hour video, right? How long is it taking me? Yes, almost an hour video. बात ये कि आप जब ये वीडियो देखेंगे ना, if you watch it properly, it will not take you an hour. It will take you, even if you watch it into 1.5, it will take you 1 hour, 25-30 minutes or even 2 hours to watch the single past paper, because during this past paper I've given you so many concepts that you don't even know about, right? मैं बीच में हर MCQ में घुसाई जा रहा हूँ जितना मुझे उसके इर्द गिर्द बातें महसूस होता है कि मैं बताऊँ सब कुछ घुसा रहा हूँ. So remember, solving the MCQ is not the objective while practicing till your June paper. The objective is to know why a particular MCQ is right and why it is wrong, and to revise your course with such teachers. The structures of 4 organic molecules are shown. It is chloromethane, that's basically a haloalkane. This is basically, it's a C carbonyl carbon bonded to the OH, so that's the carboxyl functional group. Sir, future zymatic type vibe आपको आ रही है भाई? नहीं, वो बड़े लोग हैं, हम उन लेवल तक नहीं पहुंच सकते, ना हम पहुंचना चाहते हैं, माफ़ करें सर. ओके, रमशा मेरे ख्याल में इसका पहली दफ़ा है मैंने इसे क्लास. ओके, वो महान लोग हैं यार. Okay, this is basically a carboxyl, that's hence the name carboxyl, because what I was planning on calling my channel, I was planning on calling it carbonyl. This is carbonyl. My brother wanted me to call it hydroxyl. This is the carbonyl, and OH alone is known as the hydroxyl group. Hydroxyl, carbonyl, together they make carboxyl. That's why the name carboxylic acid. ठीक है, क्योंकि उसमें C double bonded to OH, so that's the carboxylic acid functional group. And this is just the OH, which is the alcohol, and here you also have the OH, that's the alcohol. करे भाई, ऊपर बनाओ नीचे बनाओ, दिमाग ना खाओ. How many different homologous, how many different families are here? You have a haloalkane, you have a carboxylic acid, and you have an alcohol. Different families. So there are 3 different families: halo, carboxylic acid, alcohol. That's 3. Which statement creative? I know that. Yeah, I know. Which statement about ethene is correct? Ethene is an alkene, and this is, you dumbo, an alkane, because if it were ethene is C2H4. Hydrogens are twice the number of carbons. So if carbons are 2, hydrogens should be 4. This is ethane. It's an alkene he's shown. It burns in excess oxygen to produce carbon dioxide and water and large amounts of energy. Yes, it does. That's called combustion, you dumb person. It reacts with bromine to produce an orange solution. No! An alkene is reacting with bromine to decolorize it. Bromine is orange. Br2 aqueous is orange. Remember, Br2 aqueous is orange, Br2 liquid is brown. So Br2 aqueous, in your course, he only talks about aqueous. So if you have Br2 aqueous, मैं एक बच्चे को पढ़ा रहा हूँ आजकल, foreigner है, तो 1-on-1 में. खैर, तो वो ना aqueous नहीं कहते, he says aqueous. So I'm also going to start calling it aqueous because that's the proper pronunciation for it. So aqueous, it's bromine aqueous is a part of your course, and not bromine liquid, but it can say bromine liquid at times. Remember, bromine liquid is basically, where is this accent going? Bromine liquid is brown, yeah? Yallah habibi. So it does not turn it into orange, it decolors it. How does it decolorize? Well, oh my god, man, are you living under a rock? That's bromine aqueous. The double bond right here, this this double bond, this is gonna break, and the Br is gonna be bonded at one side to this carbon and the other side to that carbon. So the bromine aqueous, which was orange, is going to decolorize because it's gonna be a part of this alkene now, right? It's gonna make a haloalkane. Okay, so that's why C is wrong. It reacts with oxygen to form ethanol. Sir, it does not react with oxygen to form ethanol. It reacts with steam to form ethanol. And you have acidified phosphoric acid, temperature of 300 degrees Celsius, and a pressure of 60 atmospheres or 70? 60 atmospheres or 70? 70, 60? 60? पढ़ाया भी मैंने, भूल भी मैं गया हूँ. Pressure of 60 atmospheres, I think, if I'm not wrong. Ethanol is, yes. Ethanol, thank you, Maha. Maha is, Maha reminds me of things that I've taught. Ethanol is manufactured by fermentation of sugars or by catalytic hydration of ethene. We know that. Which statement is an advantage? Sir, fermentation does not produce purer ethanol because when we perform fermentation, remember I taught you guys how to make alcohol at home. I taught you guys कि शराब घर पे कैसे बनानी, और मैंने आपको बताया था सबसे पहले when you take your fruit, whichever fruit you want to make the alcohol out of, you take that fruit and you crush it and then you add water to it. And I explained why you add water to it. Why? Because you don't want the yeast to die when ethanol is formed, because ethanol kills yeast, right? Yeast is a bacteria, so it's gonna die if ethanol is in a very high concentration. So this does not give you purer ethanol. It gives you around 15% of ethanol. That's why we perform fractional distillation afterwards to get purer ethanol. So A and B are wrong. Yes, it uses renewable resource, which is glucose. And what is the advantage of hydrogen? Batch process or continuous process? Sir, continuous process. Some of you guys get confused. Sir, what is a batch process? A batch process is a slower process. Continuous means it's a quicker process. That's the advantage. Or batch process hota kya hai? Sir, batch process is a process, basically what it is trying to tell you is your fermentation is actually a batch process. How? Because, glucose ethanol is going to form first, and then in like 5 to 10 days. And then you're going to shift it to another batch where fractional distillation is going to take place. So there are different processes. When there are different steps involved, different processes involved, we call it a batch process, right? So this is one batch is going to produce here, then he's going to go into the fractional distillation chamber. And let's suppose the fractional distillation chamber takes 15 days. Let's suppose, assuming this, right? So if the fractional distillation chamber takes 15 days and you're producing ethanol in 5 days, तो 5 दिन के अंदर ये इधर घुस जाएगा, फिर अगले 5 दिन ये बेचारा इंतजार करेगा, because this will take 15 days. So it slows the process down, right? बचपन में हम ऐसी चीजें मैथ्स में पढ़ते थे, हमारे वर्ड प्रॉब्लम्स जो होते थे. With statements, अब तो आप माशाल्लाह सारे शॉर्टकट्स के आदी हो गए. With statement अगर ये होगा तो ये करें, वो होगा तो. Which statement about unsaturated hydrocarbons are correct? Unsaturated means at least one carbon-carbon bond is not a single bond. It can be a double bond, it can be a triple bond. So hydrocarbons are, what are hydrocarbons? Are compounds containing carbon and hydrogen atoms only, yeah? So they contain both single and double bonds. Yes, like your alkenes, they have single bonds, but they also have double bonds, and that's why they're unsaturated. Then it says they turn aqueous. They turn aqueous bromine from colorless to brown. Oh, sir, aqueous bromine is not colorless. Yaar, aqueous bromine is orange or brown. Orange if it's aqueous, or brown if it's liquid. So even this statement in itself is wrong, because aqueous bromine is orange, not brown. So it goes from orange to colorless, not from colorless to brown. If it said liquid bromine liquid test agar karta, to phir hum kehte brown to colorless. Still, in either case it's wrong. They can be manufactured by cracking. Sir, bataye ji, can they be manufactured by cracking? Absolutely they can, yaar. Alkenes की birth ही कैसे होती है? How are alkenes formed? The need for alkenes came when your larger chain, वो मैंने आपको टैक्सी ड्राइवर की कहानी नहीं सुनाई थी, उसने मट्टी का तेल डाल दिया पानी में, which is kerosene, राइट? उसने मट्टी का तेल डाल दिया, उसने इतना लॉन्ग चेन हाइड्रोकार्बन डाल दिया और इतना लंबा चेन हाइड्रोकार्बन था कि उसको कार में नॉकिंग हो रही थी, उसको हम कहते थे कार नॉकिंग हो रही, राइट? सो देयर वाज कार नॉकिंग दैट वाज टेकिंग प्लेस. सो दैट इज व्हाई यू ब्रोक दैट, यू क्रैक्ड दैट लॉन्गर चेन less useful hydrocarbon into more useful hydrocarbons, which are basically your smaller chain alkenes and alkanes. So that was how alkenes were birthed. So yes, 1 and 3 are correct, and therefore B is the correct option. Which polymers have the same linkage? It can be the imide linkage, the peptide. Carbohydrate is no longer in your course, but the linkage for carbohydrates is a glucosidic linkage. Who cares? Right? So carbohydrates, he's talking about starch essentially. So starch jab banta, it's a polysaccharide, so it has a glucosidic linkage. Polyamide has an imide linkage, right? That's why it's called a polyamide. Your proteins and nylons. Carbohydrate, again, polyester, wrong. Carbohydrate has a completely different linkage, which we call the glucosidic linkage, not in your course anymore. Protein and polyamide. Polyamide contains the imide linkage, and protein also has the imide linkage. That's why protein is called a natural polyamide and nylon is called a synthetic polyamide, and you can call protein and nylon as polypeptides as well. But polypeptide is more specifically used for protein because you study this in biology, the peptide linkage. So in bio you call it the peptide linkage, but in chemistry we call it the amide linkage because of the carbon-carbon bonded to N group, right? Protein and polyester, no sir, protein has the amide linkage and the ester has the ester linkage. So, oh, why did I cross C out? C is correct, yeah? They both has this amide linkage. Why did I put a cut on it? The diagram shows partial structure, sir, of pterylene. Pterylene ka partial, okay, even if you knew that it's pterylene, you know pterylene is made from dicarboxylic acid and diol. Ain't that true? It's made from dicarboxylic acid and diol. So check this out. That's my dicarboxylic acid and that's my diol. A is automatically correct. But let's suppose you did not know it. Let's suppose bhul gaye, paper mein bhul gaye. Kya karna hai? Sir, dimag ladai. I taught you guys how to go into the monomer of each structure. We put a cut at the linkage, put a cut at the linkage, put a cut at the linkages, right? So when you put the cut at the linkage, between two cuts you have the monomers. So that's your dicarboxylic acid and that's your diol. Yeah. So this will get back the H, this will get back the H, and this will get back the OH, and this will get back the OH. So that's A, right? I could make it for you. That's this box, OO, and this is carbonyl carbon. That's the box, that's carbonyl carbon. So this gets back its OH, which is lost because it's a condensation polymer, and these gets back its H. So that's A is correct, and that's done and dusted. Obviously, I don't need to check the marking scheme because I'm pretty sure every option is correct because we used all our logic. One student can tally it with the marking scheme, please, for me. Yeah? I'll stop the recording here, and you guys can ask me any question with regards to general life or just chit chat or anything. Nahari Singh, recording milegi? जी recording ही है. You guys can ask me question with regards to anything essentially, right? I'm here for the next 15 minutes. So till, not 15 minutes, till 7:25 I'm here. Okay? Ask questions. Go away. No, go ahead. Let me stop the recording.